Let's talk about vertical rescaling of exponential and logarithmic functions. So what we're used to, what's familiar is something like 3 to the x. We know that graph's an exponential growth, so let's just draw it like this, and it's crossing at 1 because 3 to the 0 is 1. Now, what if we do something like, let's do like y equals 10 times 3 to the x. So everything in this function is being multiplied by 10. Every y value is being multiplied by 10 because it's 10 times the previous y value. So now, when we plug in 0 for x, we're getting 10 times 3 to the 0, which is 10 times 1. So going up to 10 here. So the end result is that it's kind of like you're taking the y-axis and you're imagine you've drawn this function on like a rubber or balloon type latex fabric, and you're pulling it up, you're stretching it, and the function is following with your stretching. So the function is stretching upwards. Likewise, if we do like y equals 1/10 times 3 to the x, it's like we're compressing downwards. So we're taking this function, everything is being divided by 10, or you can think multiplied by 0.1, just write 0.1 here. So 0.1, and then it becomes a lot more smushed. So looking something like that. Now with logs, it's a really similar idea. So if you've got y equals, say, log 3 of x, then originally you're looking at something that looks like this, crosses at 1, and its next point is at 3, and that's when the y value is 1. Now, if you take y equals 10 times log 3 of x, then now this point is staying at 0 because 0 times 10 is just 0 still. But now this point that was originally at 1 is going up to 10. And this point, say this point was originally at like -1, now this is going down to -10. So it's looking something like that. It's like we've stretched it. It's like we're stretching, and the center of stretching is at y equals 0. So things that are further away from 0 get stretched more. And then likewise, if we have y equals 1/10 log 3 of x, then now this point is dividing by 10, so going to 0.1. And this point is also divided by 10, so going to like -0.1. So it's going to look something like that. And that's what we get if we like smush the function.